This lesson is going to focus on the different types of angles that we can have and using the Cartesian plane to graph. As you recall, excuse me, we have three primary trig ratios, sine, cosine, and tangent. And depending on the angle that we're looking at, these values are going to vary. Our focus in this course is going to be for angles that are between 0 degrees and 360 degrees. Now there are three parts to the angle. So there's the angle value itself, which is what we call the principal angle. So for example, this could be 360 degrees, or it could be 221 degrees, or it could be 2 degrees. The next two terms that we're going to use refer to the terminal arm and the initial arm. The initial arm is always going to be located on the x-axis. Your terminal arm is going to be located somewhere else. It could also be on the x-axis depending on the angle that we're talking about, but in general you always have your initial and then your terminal. When we're dealing with these angles, we're going to be going in a counterclockwise position. So if we're talking about an angle in standard form, the vertex is at the origin. So right here, your initial arm is on the positive x-axis, and then your terminal arm is somewhere else in the quadrants. Now, your principal angle always has to be between 0 and 360 degrees. We have positive angles. So if I were to draw my initial arm here, and then rotate all the way to here, and then draw my terminal arm, this angle here would have a value that is a little bit over 180 degrees. So we start rotating 0. We hit this value, it's 90. Half a circle would be 180. Then we have 270. And then finally, if we go one full rotation, it's 360, which makes sense because if you think of doing a full circle, you've gone 360 degrees. Now, a negative angle, you're still starting from the positive x-axis, but instead of going counterclockwise, you're actually going to go clockwise. So I can have an angle in that exact same spot. So this one, because I'm going counterclockwise, this is going to be a negative value. This angle over here is a positive value. So that letter that I just used, it's a Greek letter called theta. It's often used to represent angles. Now, we're not going to worry too much about this, but just so you're aware of the terminology. So coterminal, the angles that I have up top here, those are examples of coterminals. So even though I came to them in two different directions, they actually land in the same spot. So there are basically multiples of 360 degrees. So if I were to draw an angle at 60 degrees, so if I check this right here, I'm going to draw a coterminal angle. So I'm doing one full rotation to get 360, and then I'm going to go an extra 60. So this angle would be 420, since we have 360 plus that initial 60 degrees that we had gone. So as long as you have an angle, you can always find a coterminal angle by adding 360 or subtracting 360, depending on the direction that you want to go in. Now, the next most important thing is something called a related acute angle. You have your principal angle, which is any angle between 0 and 360, but your related acute angle is exactly that. It's an acute angle. So it has to be between 0 and 90. That's where the quadrants come into play. In each of the quadrants, you can have an angle that's bigger than 90 degrees, but the related acute angle is always going to be less than 90. So in quadrant 2, for example, let's draw an angle of 120 degrees. So I'm starting here on the positive x-axis and I'm rotating 120 degrees. The related acute angle in this particular example is 60. Now, how did I come up with that? Well, I know if I had gone the full rotation, I would have gone 180 degrees. But because I'm stopping at that value, I'm 60 degrees away from it. So in quadrant 2, it's going to be 180 minus whatever your angle is. That will always tell you what your related acute angle is going to be. Because you haven't quite gone that 180, you're a little bit shy from that. Now if I were to do the same kind of thing, so let's pick an angle that's bigger than 180. So let's look at 225. So I'm going to start, I'm going to rotate. All right, so I've gone 180 once I hit the x-axis, the negative x-axis. And then how many extra degrees do I need to go in order to get here? So right here, this whole red angle is 225 degrees. I want to know what this little angle is right here because this is my acute. So I'm pointing at the angle that's made between your terminal arm and the negative x-axis. So this angle right here is going to be 45. And how did I come to that? Well, I had theta, which is the 225, minus 180. So that tells me what that particular angle is going to be. Now, the fourth quadrant, we're going to go through the same process. So let's say I take 310 degrees. So I'm going to start, so I'm going to go to about here. This is a rough estimate. So I know that this is 310 degrees. If I'd gone that full rotation, so if I were to extend this, that would be 360 degrees. I'm actually going to remove that. So that means I need to go an extra 50 in order to make it all the way around. So as long as you know where your angle is located, you can always figure out what your related acute angle is based on its positioning. We're always comparing to the x-axis. And ultimately, we're going to be making right triangles to help us determine specific values. So in this example, we're just going to look at all four possibilities. So here, this is your principal angle and your related acute. So I'm just going to put the P and the R with it. So this is in quadrant 1. If you have an angle between 0 and 90 degrees, your related acute and your principal are going to be the same value. Now in this example, we have 30 over in this location. So this is my related acute, but my principal angle. So if I'm looking for my principal angle, if I had gone the whole way, I would have been 180 degrees. So your principal angle is going to be 180 minus 30, which equals 150. So the actual angle you're looking for is the 150, but we're using the 30 to help generate it. Now down here, same idea. So our related acute is 30 once again, but we've gone 180 plus 30 to give us a principal angle of 210. So using that reasoning, one full complete rotation here would give us 360. Our related acute is 30, so our principal must be 360 minus 30, which equals 330 degrees. So this is using our coordinate plane to help us identify where angles are. Why are we worried about these related acute angles? Well, in the next unit, you're going to be looking at special angles and how we can use this to help us identify what angles are. So here we have an example. So it says, given angle 230 degrees, sketch the angle. So let's start by doing that. So I have a coordinate plane drawn here. So we're going to start on the x-axis. I'm going to rotate. So I'm at 90, we're at 180. So 230 degrees is going to be in here somewhere. So I've sketched that 230 degrees. I'm putting the little arrowhead to show the direction that I'm turning in. Then it says find the principal angle. So our principal angle is 230 degrees. Because remember, principal is between 0 and 360. Now the related acute angle has to be between 0 and 90. So that's where this whole idea comes into play. Half a rotation is 180. How much extra did you have to go? So your related acute angle is going to be 230 minus 180, which equals 50 degrees. So we know this little angle down there has to be 50. Satisfies our condition for being the related acute because it's between 0 and 90. So same kind of example, sketch the angle. So I start rotating. I'm starting again at the positive x-axis, 90 degrees, 180, 270. Okay, I have to keep going. So I'm going to go all the way over here. So that principal angle has to be 347 degrees. Now our acute, if we had gone the full distance, we would have gone 360. So for our acute angle, we're going to have 360 minus 347, which equals 13 degrees. So as long as you can graph your angle, you can figure out that related acute angle very easily. Okay, just to give you an example with the negative, I apologize for that little announcement there, so we'll just continue again. So this one is a bit different because of the negative angle, but we're still going to work the same way. So negative angle, we still start at the positive x-axis, but instead of going counterclockwise, we're going to go clockwise. So I'm at negative 90, negative 180. So I have to go a little bit extra to end up here. So I'm actually going to do the acute angle first for this one. So if I go that full rotation to this location right here, I'm at 200, negative 200. I'm actually at negative 20 here, or sorry, negative 180, which means this acute angle has to be 20 degrees. We've sketched the angle, that's good. Now our principal angle, remember by definition, is between 0 and 360. So that's this red value that I have right here. That's why I did the acute angle first. Because if I go all the way to here, that's 180 degrees. But I haven't. I've gone 20 degrees shy of that. So that means our principal angle has to be 160. And if you'll notice that 200 and 160, they combine to give you 360. That's not a coincidence. It's because you're doing a coterminal angle for that particular example. All right, bear with me. We have two more examples. So here, it's giving you a point. So it's a different way of asking this question. So 3, negative 4. So I'm going to plot that. 1, 2, 3, 1, 2, 3, 4. So I have this here. So that's my terminal arm. From there, I'm going to make a right triangle after I show where the primary angle is. I'm going to make a right triangle. And this is important because I know that the y value is negative 4 and the x value is going to be positive 3. And I could tell that simply from my coordinates. Now, because I want to get all the primary trig ratios, I need to be able to come up with a value in order to figure out the hypotenuse. So we have a right triangle, so I need to figure out what the hypotenuse is. So we can use Pythagorean theorem to determine that value. So we have h squared equals 3 squared plus negative 4 squared. So h is going to equal the square root of 25. So our hypotenuse is going to equal 5. So now when we look at this, we want to state our primary trig ratios. So for MB, I know that the sine of theta has to equal opposite over hypotenuse. So that's negative 4 over 5. So my angle that I'm going to look at is in here. Cosine of theta is going to end up being 3 over 5. And then tan of theta is going to end up being opposite over adjacent, so negative 4 over 3. In part C, you're being asked to figure out the value of theta to the nearest degree. So if you take your calculator and you do theta equals the sine inverse of negative 4 over 5, you're going to end up with a value that's about negative 53 degrees. The problem is we want to know what that answer is in terms of the principal angle, which is the positive angle. So that means this angle in here is 53 degrees. So my principal angle is going to equal 360 minus 53. So that's going to be 307 degrees. You could do the same thing with cosine and with tangent. If you work out this cosine value right here, it's going to give you the positive 53, which is fine because that's still your acute angle. And again, over here, if you do this here, you're going to once again get the negative 53 degrees. So either way, any of those methods will give you that angle. You just need to recognize that it has to be translated into the principal angle notation. Our last example, so we're actually not going to do this one right now. Hopefully this stuff makes sense. If not, just send me an email and I can answer questions or direct you in the right way. Please do the worksheet. It will help enforce what we're doing here. If you still have issues, please, please, please email me.